Alright, here's the notes for section 9.3, and this section is going to be about experimental probability. Up until this point we've been talking about theoretical probability. So for example, if you wanted to figure out the probability of rolling a 3 on a dice, well, that would just be 1 3 out of 6 sides, or 1/6. But let's say you want to actually do an experiment, or you want to actually see if that's true, or if you want to test one particular dice and see if it works out to be what you would expect, which is 1/6 for rolling a 3. What you could do is a little experiment. You could roll a dice 600 times. I know that's a fair amount, but if you had some help, it wouldn't take too long. And let's say these are our results here. We got a 195 times, 2 117, 3 105 times, 498, 5 104, and 6 happened 6 happened 81 times, excuse me. So these are our results from our experiment of rolling a dice 600 times. We can use these results to come up with a probability, and this is called experimental probability. So according to these results, we threw a dice 600 times, and out of those 105 were a 3. So our experimental probability for rolling a dice 600 times is 105 out of 600, which is very close to what you would expect, 1 out of 6. So just to define it here a little bit, experimental probability, the probability of event, remember this P in parentheses is just shorthand way of writing probability of. So the probability of a specific event is the number of times that event occurs over the total number of trials. So again, going back to here, we had 600 trials, and a 3 happened 105 times. So the probability of rolling a 3, according to this experiment, is 105 out of 600. So instead of just thinking about it and coming up with a probability, we're going to actually look at some experimental results and use those to find the probability. And in your homework, you'll have some bar graphs to look at. I didn't have the time to make a nice one out of those numbers, but you'll get those numbers out of a bar graph a lot of the times. Okay, so just a few other things here. Another quick little example. Let's say you wanted to figure out what the probability of flipping a tails on a coin is. Well, what you could do is flip the coin 500 times, right? Flip it over and over again, 500 times. And if you do that experiment, here we got heads was 375 and tails was 125. So that's 125 out of 500 according to this experiment. Now we would expect it to be half because there's one tails out of two sides, right? We would expect it to be about half, but this is a lot less than half. So based on these results, 500 times isn't really that many, but 500 is a good size to start with. We might not have a fair coin. We might have a coin that lands on heads most of the time. So if I were really trying to investigate this, I would do this experiment several more times and see if this number got closer to a half. And if it didn't, then I would conclude that I had a coin that landed on heads more than it landed on tails. So again, you're going to use data, you're going to use results to determine your probabilities in this section. So just an example here, while I was working this out, I was thinking about it. There was a prisoner in World War II who was curious about this same problem, except he was looking at heads, but really the same idea. And he was locked in a jail cell for a long time. And so he and I think one partner, they flipped a coin 10,000 times. 10,000 times, that's a lot. And it turned out that he got 5,067 heads. And 5,067 out of 10,000 is really close to 1/2. So usually in a situation like this, the more trials you do, the more your result will approach what you would expect based on the theoretical probability. So anyway, again, just to go back here, we're going to use results from experiments to determine probabilities in this section, and you'll have to read the data off a chart to figure out how to get your answers most of the time. I hope that helps. If you have any questions, please let me know. Thank you.